All right, so we're going to start actually with Dylan is going to talk to us about the introduction to the J750. It is the newest offering from Stratasys with faster speeds, full color, and finer resolution. Then we're going to have a little discussion between Dylan and myself about some extra features, along with some questions from the audience and attendees here, so we can get you guys all the information that you want to get out of today's webinar. So Dylan, why don't I hand it over to you, and you introduce us on everything you want to tell us about the new piece of equipment.
Alrighty, sounds good. Thanks, Derek. Thanks everybody for jumping on. Appreciate it. So I'm going to run through some of the actual technical specs on the printer, some high-level discussion on the software, general applications, and some of the things that we're excited about with this printer. So first of all, I wanted to just touch on a little bit of the history. So this is the next generation in the PolyJet line of hardware from Stratasys, originally the Objet line. And starting out in 2004, the Eden really hit its stride when it came onto the market in the US, and it really changed things in the industry, because before you really had predominantly stereolithography and FDM as the main technologies. And in the photopolymer realm, stereolithography was a little bit limited in its speed and resolution and the versatility of materials at the time. So when the Eden came out, it offered an inkjet-based photopolymer resin system with toner cartridges that was had great accuracy, great details. It was just very easy to work with and user-friendly. So that system and that platform was very popular for quite some time. And then the next generation came around in 2007, and that's when things really got exciting, in my opinion, when the Connex 500 was released. That was the first machine ever to run two materials simultaneously with different material properties, and that really unlocked the door for being able to print rigid and elastomeric materials, translucent and opaque, and combinations to help better visualize and simulate products in the earlier development stage. And so that was an extremely popular machine, still is an extremely popular machine. And then came along the Connex 3, the Connex 1, 2, and 3 platforms in 2014. And that really pushed things even further. That was the first time where we started to see color with 3 material color palettes, as well as an ability to run the very popular ABS-like simulant and overmold that, which has been extremely popular. So that machine just gave us more versatility and more exciting features with 3 material combinations. And now with the release of the J750 here in 2016, Stratasys has released a material that's running 6 materials simultaneously plus a support material. And it's the first time that we've had a full color 3D printer with a robust material that you can actually get some testable models out of, where in the past you were dealing with more plasters or paper for color. So super excited about the history. It's a very proven platform, and this latest generation is a huge step forward, in my opinion. So getting into some of the actual highlights of the printer itself, we can kind of go into what's the same and what's different, what's similar. For those of you who are users familiar with the Eden or the Connex systems from the past, you're going to see similar things with high speed, high mix, and high quality. In this case, in high speed mode with this machine, you're running at 27 micron layers, which is going to be similar speed to your Eden and Connex and Objet Connex 1, 2, and 3 high speed modes. But you can run that speed with 3 materials running simultaneously. So that means if you like to run the ABS composite, that ABS simulant, instead of it running at traditional digital material speed, you can now run it in the equivalent high speed mode, which is very exciting. So any 3 materials you want to run, you can run twice as fast as before. Now the other mode would be high mix, so that's when you're running any 6 materials. That's also going to be in 27 micron layers. And you're going to be then with 6 materials in the same speed range as you had with 500 and Connex 3. And then a new mode, high quality multi-material mode, which I think is very exciting. You can now run all 6 materials plus support at 14 micron layers. So Traditionally in the past, if you wanted a high quality model in the previously 16 micron layer prints, you could only really run one material. So anything that was multi-material was always going to be that 30 micron layer. So that's a very exciting improvement for sure. So moving on from the actual print modes, there's a new software suite. And the new software UI has been totally redone, and it's very improved in the way that it allows for color assignments, either through shell-based color assignments or now through VRML texture-mapped mesh imports. So you can now import your color model files the way you have traditionally in the past with either plaster or paper-based color printers. And then on the materials front, we have an even wider color gamut, and we have an improvement in the base resins of Vero White and Vero Cyan. They have become brighter, more opaque, and more vibrant, which is yielding an even better and more accurate color palette. So some highlights on the printer itself. You're going to be able to run the engineering grade digital ABS material all the way through the Vero line of general use plastics, so a big range of materials. You can run your same 3.6 kilogram cartridges that you ran on your Eden Connex or Connex 3, so the cartridge size and compatibility is going to be consistent. You can run, of course, single material to overmolded parts, single color if you're just doing shell-based assignment, to full color with texture map, flexible to rigid, matte and glossy, mixed tray, mixed part, so you could have some parts on your tray that are going to be in a matte mode, some that are in glossy. And then you can do, smaller, finely detailed parts, all the way to larger, more robust tooling and things of that nature. So, hard to soft gradients that you're familiar with. It's just a lot more and a lot better of things that we were experiencing off of the Connex 500 and Connex 3. But that last point there on shells versus texture map VRML is a big deal because it was one of the limiting factors previously with the Connex 3. Now they've released a software package around that helps unlock some textures there, but with the 750 it's coming right out of the gate with the new UI and the ability to run VRML files. So very excited about that. So here's a couple examples just kind of showing some of these you might have seen online, some of you may not have, but wanted to call out some of the materials there. So you're getting Vero Black, Vero Cyan, Magenta, Yellow, White, and Tango Black Plus in this case. So you've got your CMY, K for black, and then white. In most color printing, white is your substrate, but with this technology you're actually depositing the white pigment. You need a color channel for white as well, which took some figuring out. So, and then you also have one extra bay left, so that in this case they're running the Tango Black Plus, which allows them to call out varying shore values from shore 27 all the way through shore 95A, so they can assign either the lowers on the shoe a different shore value for testing and comparison. So here's another example. This one is going to be basically highlighting again being able to run CMYK and then W and clear in this case for the screen. This is actually a two-build assembly because you'll also see some elastomeric knobs and buttons on the right side of the part. So through a couple prints you can get an even wider range of properties. In this case, if you didn't need to simulate the screen, you could have had the elastomer buttons in there as well. But you can see the variety of colors and range, and very crisp in those 14 micron layers. All right, so moving into some of the benefits here. You got 360,000 color gamut, which is really, really great because you get a huge range of colors. You're getting in a more true-to-life color matching and really accurate and repeatable color, which is what's most exciting, I think, about the PolyJet color. It's traditionally with color prints, you were lacking robust materials, you were lacking accuracy, you're getting deformation. This proven technology now with full color is just a great improvement. Being able to move into color gradients and color texture mapping unlocks even more potential over the traditional shell-based color assignment in the past. And then being able to introduce not in just color but also elastomeric materials and transparent materials along with color can yield some really exciting models. The example on the right there, you can see a really wide range of materials going on, and you can just see how much you're able to communicate visually by having access to all those different colors and material properties within a visualization model. So the digital ABS with overmolding is a huge benefit, because anytime you're blending with ABS-like as your rigid parent material with your Tango Black Plus or Tango Plus, you get a better strength on your elastomer. So being able to run that digital ABS with overmolding in half the time that you could with the Connex 3 is a huge deal. So that's going to just give you that much more throughput. A lot of folks, might really like the ABS, but in the past it took them a little longer to print, so they would maybe default back to a Vero material. Now with this machine, you can run those parts much more quickly, which again for tooling is a big deal as well. If you're doing prototype injection mold tooling, being able to run those larger tools more quickly is huge. And then of course, if you want some colors for color visualization, same thing goes. You can run any 3 materials twice as fast as you could with Connex 3. So, and then of course having 6 materials on demand means you've got very few material changes in your future, most likely, because a lot of our power users have, they have their favorite materials, their go-to materials, and I would say it's pretty rare that somebody has more than 6 common go-to materials at a time. So keeping that in mind, if you're running a service bureau, running a studio at an enterprise level customer or client, you're not going to have nearly the material swaps or the juggling in order to accommodate all the requests that you might be getting for different properties of material. So a big part of it, of course, the hardware is great, but how do you get that data into the printer effectively and cleanly? So they've redone the whole UI completely and really tried to streamline the way you can go to either color assignment within the software or importing of previously assigned color models from your traditional CAD packages where you might have been producing and assigning color. So they've made great efforts to improve that and make it more streamlined. This next slide, you can get an idea of what the software interface looks like. Like I said, you could either import your multi-body assembly into this software and then go through and assign by color individually by shell, or you might have fully fleshed out texture map models in a third-party software, in which case you can just save out as a VRML file and import right into the software with all your color assignments and textures, UVs intact. So that's a very clean and efficient way to go for sure, or if you want to go shell-based, you have that option as well. Usability functionality is going to be very consistent with previous versions of Object Studio. New version is called PolyJet Studio. It really just improves on how it handles color. Is the main difference there. So from a usability standpoint, there's not going to be a huge issue on the learning curve side getting comfortable with it. So because of the detail, now that we're doing these 14 micron 6 material prints, you can really get into capturing a lot of detail. This shoe model is pretty cool because you can see that there's actually sculpted texture into the leather itself. Softwares like ZBrush or Mudbox, different software like that where you can get into projecting 3-dimensional textures onto models or sculpting textures into models. That actually can get printed out and communicated very clearly, right down to the stitching details. So you can get some very, very exciting models and a lot of accuracy and detail with that 14 micron 6 material printing. And again, a lot of limiting factors with color in the past has been the strength of the part that you get and then the actual vibrancy of the color. With PolyJet resins, they're very pure and the color is very bright. With the new Vero Cyan and the new white, you just even get brighter whites and more vibrant colors. So I'm very excited with the color output and the quality that you're getting there. So as far as just general benefits, if you're looking at, medical device, surgical planning and things like that, you're getting much more accurate and detailed planning models, getting much better just data visualization, much better true-to-life prototyping earlier in your development phases. You're not having to go out of house to get to those secondary stages in your development to communicate some of those downstream things like you know, your CMF and things like that. So you can really early on start to visualize both tactily and visually these new materials and colors. You're going to have faster product development because of that, quicker iterations, quicker decisions. You know, if you're using this on a sales side, marketing side, you're getting much more accurate and realistic sales and marketing models earlier in the process without having to spend as much on those individual models. And certainly more efficient enterprise level prototyping for those larger clients where they're running a lot of jobs for a lot of folks on their campus. Having all that versatility of any 6 materials on demand at a time is a huge relief for somebody running those facilities because they know they can accommodate a large range of requests on any given day or night without having to juggle timing and pushing out schedules. And just in general, it's going to yield more productive manufacturing facilities. We're seeing just a lot more usage in jigs and fixtures and now low volume injection mold tooling and things like that that we're exploring heavily at Fathom. Being able to run those tools, those more robust parts in the ABS-like material twice as fast is going to be a big deal for a lot of companies. So just jumping into a couple examples here. You know, this machine just came out, so there's not a whole lot of user case studies, but we wanted to highlight just a couple of them so you could get an idea. Synergy, Stratasys customer running the 750, has really liked how they can communicate so much so early in their process. You know, prior, you know, there would be a lot of different outsourced services that they had to deal with in order to get a decision made on a model. With the ability of texture map color and elastomer color and translucent materials, they were able to skip a lot of those extra steps of having to do things like CNC machining, water printing, casting, sanding, engraving, pad printing, you know, things that are just going to take a lot of time to get those models back. When running the J750, they're able to reduce those lead times tremendously, you know, 2 weeks to basically a build time, so a few hours. Maybe overnight if they're doing a whole tray of different ones. And it's going to cut the cost of prototyping for these guys tremendously. So Synergy was seeing very early benefits from the new hardware and software. A lot of beta sites very excited about this hardware, and I'm very confident that it will be very popular out there for Stratasys and for our customers. So going in just a little bit to some of the nitty-gritty specs. For those of you who are familiar with Eden 500, Connex 500, and the Objet 500 Connex 3, the box size is roughly the same. If you're a Connex 1, 2, or 3 user, it's virtually exactly the same. The big difference here is going to be there's a second material cabinet, which adds another few square feet adjacent to what would have been the original cabinet on a Connex 3. So footprint is about the same, just that additional material locker to accommodate all of that material. So you have 2 material bays per material plus support. So you know you've got quite a few different slots there to fill, and so having those material lockers means you're going to have less swaps of cartridges because it can auto change over between cartridges just like you had back on the Eden Vs and the Connex 500 and the previous generation. So moving on, build size is going to be consistent with what we've had in the Connex 500 range in the past. Resolution 600 by 600 has remained consistent. The Z-axis DPI has improved, now being able to get down to 14 micron layers, 1800 DPI. On the software side, like I mentioned, PolyJet Studio is the next generation of the software driving the PolyJet machines. It really incorporates and builds in a backend to handle the texture mapping as well as color gradient and color assignment. And the file formats are going to be STL and VRML. As far as the material delivery goes, you've got, like I mentioned, the 6 different material bays, 2 for each material plus 4 support. So you're going to have ability to hot swap between materials, switching either from NE3 to NE6. You can run in the small cartridges still. For those of you who just sample materials from time to time and don't want the larger 3.6 kilogram, you can still run that smaller size. And then the workstation compatibility, Windows 7, Windows 8, 64-bit. I'm sure Windows 10 is not too far behind, but those are going to be the main operating platforms. And then power-wise, same deal as before with Eden and Connex, standard 110, no huge power draws on these printers, and then the regulatory compliance down there as well. So just improvements over previous hardware, no dramatic changes in size or in power consumption or anything like that. So I just wanted to touch as well on materials. So like I mentioned before, all the materials you've been using in the past, if you're a current user, will be able to run in this machine. But there's some additional materials. The options for you, of course, in the full color with the Vero Cyan, Vero Yellow, Vero Magenta, the improved white. Of course, you've got your whole Tango family of elastomers, Tango, Tango Black Plus, Tango Black, Tango Gray, which are going to be Shore 27s, Shore 62, and Shore 75As, respectively. Your digital ABS, digital ABS 2. A lot of people ask about that. What's the difference? Really, ABS 2 is a software tweak to accommodate thinner walled parts. So because digital ABS is a blend of a part A and a part B, one being stiffer and high temp, the other being softer and lower temp, when it's depositing a dot matrix on a thin wall, there was a tendency at times for it to have too much of one or the other, resulting in a soft vertical wall, if you could imagine that. So the digital ABS 2 was an update that allowed an option to control more of the part A rigid material into that thin wall feature, which resulted in a stiffer thin wall. So generally you're going to run standard, but when you do have those fine features, that's what digital ABS 2 is all about. And that's still coming in ivory or the green. And then on the transparency side, you've got Vero Clear and Full Cure 720, now RGD 720. A little naming convention change there recently. But those materials, of course, are still running. And those can be run in conjunction with your color materials or your elastomers. And then on the digital material side, that's where, in my opinion, things get very exciting. Digital materials, definitionally meaning the ability to take two different materials and through software and inkjet allow for a dot matrix patterning of the two materials that results in a unique material blend. That's how we're able to take a rigid, say, Shore 85D and a soft Shore, let's call it a 27A, and then create a range of different elastomeric properties or rigid tints just from two materials. So two materials unlock another 12 or 16, and then you multiply that out by all the other materials that you can blend over 6 bays, and you can see that the potential for huge variety and blends on the new hardware is just completely unmatched. So super excited about the potential for digital materials on the 750. So that's kind of the main run through as far as the hardware is concerned. I think we'll dive into a brief Q&A on some general questions that we assume people will have, and then we'll open it up to Q&A from anybody who's on the line and has some questions after that brief intro. So Derek, are you there?
I am. Dylan, awesome, great information on the J750, but let's start off with probably at the tip of everyone's tongue is everyone wants to know how much is the J750? How much is this new technology that offers all of what you just discussed?
Yes, we are preempting because we know that will be the first and probably most common question. Honestly, it's not something that we're supposed to publicize and talk about in a discussion like this. So what I'll say is we've got pricing, happy to discuss it on a personal basis with anybody who's looking at just general ballpark numbers or specific quotes given their situation. But for the purposes of this Q&A session, we're not going to be diving into specifics on pricing on the hardware. What I will say, it's been consistent with traditional flagship printers in the Objet line, but beyond that, we can talk specifically one-on-one for anybody who wants to get into the deeper dive on pricing and costs.
Got it. So it's obtainable to common customers that we'd sell to normally, or Stratasys would sell to normally, and an even more capable printer. Okay.
Yeah, absolutely.
All right, so the full color options are really exciting. We can see how the J750 is a great fit for a really awesome medical application you showed, consumer electronics and a shoe company that's trying to create models. But how could these industries as well as others utilize all the material types and capabilities of speed and combinations that this new system offers?
Well, it's, honestly, it's going to be very, very situational depending on who the user is, who the customer is. What's important to you in your workflow. If color is important, the color options with this printer are just flatly the best that there is out there, and you're getting the best material properties, the most vibrant colors, the most color gamut, or the highest color gamut for for the output, and the most accurate and repeatable color. Which just means much better visualization, more complex models with more communication through more and more colors. I mean, if you're talking about human anatomy and trying to do surgical planning models with great visualization, 1, 2, or even 3 materials might not cut it. There's a lot more going on in the human body than that many materials. So getting it into a realm where you can call out 6 different features uniquely, not to mention blended colors. You have a really very, not unlimited, but near unlimited option for assigning different colors for visualization. So you're going to communicate a lot more effectively that way. But it's not always about color for a lot of users. So what is the user going to gain if color doesn't really matter? Maybe they're going to paint, maybe their product doesn't really incorporate color. If color is not important, this platform is still extremely powerful, just given the versatility. I mean, like I mentioned before, most of our power users aren't necessarily running more than 6 different material types commonly. So knowing that you've got what you want on demand at any given time without swapping and planning is going to be huge in reducing your time to have parts in your hand. Not to mention being able to run any 3 of your favorites twice as fast as before. That's going to be hugely beneficial, especially for those users where the digital ABS composite is popular, people getting into doing some prototype tooling and things like that. Tools can get larger, and being able to run those that much more quickly is going to be very, very beneficial, because that means you're shooting parts tomorrow instead of day after tomorrow, if not same day.
Yeah, that's great stuff. A lot of diversity for people like us that run a variety of parts and different materials, and we can reduce all those changeovers. We can create models. We can even show engineering examples where features change throughout revs with different colors. It's not about color, just like you were saying. That's great. So there's a lot more to the system, though, than the colors. This is just the first offering. What do you think is going to come out in the future to support the capability of this machine?
Well, it's hard to say. We're kind of in launch mode, but looking back on the history of this technology platform, what's exciting to me is that we have a new hardware platform to build off of. So, at launch we have this huge range of colors and all these materials. With 2 materials we were able to get a dual material composite. Well, what are the benefits of having a 3 material blend and still being able to overmold that? Or maybe you have 2 different composites running simultaneously plus other materials. I mean, the potential for future materials leveraging the blending is very exciting. Another thing that's possible, that in my opinion is probably a software hurdle more than anything, is an ability to, like color gradients, do material property gradients. Now, right now, that is not something that we can do, but from what I can tell, you should be able to do those kind of property gradients in time, which would yield very interesting and exciting models, and even more functional and robust prototypes and low-volume production parts. So I think there's, just as a hardware platform, there's a huge amount to build off, and what we're getting at day one is better than anything that's ever been available in this space. So I'm very excited about it, and I'm looking forward to seeing what people come up with and how they can apply the hardware in their own workflows.
Oh yeah, it's going to be exciting to see all the parts that come out of this. But yeah, as a last note, I guess from us, Dylan, do you have anything else to close and give everyone, before we jump into the audience questions, that you'd like to leave with?
I'd just like to say that, if we don't get to all your questions at this point, or you're getting curious about specifics beyond what we touched on today, please feel free to reach out to us direct, of course, and we're happy to get into a deeper one-on-one conversation. The purpose of this today is to really give a high-level overview so people can kind of get their heads wrapped around some of the buzz and the hype of the newly launched machine. So just feel free to reach out with any deeper questions or anything that's more specific to your projects or your company.
Nice. All right, well, let's hop into a couple audience questions here. The first one for the both of us to answer is, can you get a high polish finish with this machine, or essentially how much does that improved resolution help with the finish?
So going just from 16 to 14 microns is actually a noticeable difference when you're looking at models. If you're accustomed to looking at these models, when you get into that fine of a resolution, even if you're doing finishing, the finishing is that much easier because your starting point is so much better, so much more refined already. But that being said, just hitting some of these parts with a clear coat is going to make them even more vibrant right off the machine. You can run it in glossy mode if you had a two-part assembly. You could run your clamshell housings with the outside of the model to be in glossy mode, which, if you're familiar with that, it makes it look like a clear-coated glossy model. That being said, if your part doesn't lend well to a glossy print, then running it in matte mode with very light finishing and a clear coat is gonna make it pop even more. So, right out of the machine, it's going to be great, but you can always improve on any prototype model with some hand finishing.
Great. Another one is, can digital ABS be printed in all the colors or just the ivory and green?
Great question. So right now, what I will say is it's white and green, but what is possible with this machine is that you can coat any material. So even in the PolyJet Studio software or through creating a shell in your CAD and importing, you could skin a part. So you could have the core, say, of your golf ball be digital ABS, but the skin be Vero black. So that's going to affect some of the physical properties of that part. Say if it was a snap fit or a hinge, that's going to reduce the strength of that snap fit or hinge if that feature is coated. But you could imagine from a visualization standpoint, or if you're concerned with heat and you want that higher heat deflection temperature of the ABS, you should be able to get away with coating it in whatever Vero material at a thick enough layer to have the opacity that you want.
Nice. So strong and aesthetic models can still be created right now. Even with just the ivory and green digital ABS? That's great.
Yeah, I wouldn't be surprised if in the future they did something with an ability to tint within the software, but right now you'd be looking at coding.
Gotcha. The next one on the list here is there a skin-safe material?
Yeah, so Med 610 is the biocompatible resin from Stratasys for this machine. And for all the PolyJet machines that are capable of running it, which the 750 is one of them. That is a 85D rigid, transparent, call it a clear material. So it's going to look visually just like the Vero clear material, but it is rated for, I believe it is 7 days skin contact and 24-hour subcutaneous. So as long as the sterilization protocols are followed and the user follows the purge protocols, then you can get a biocompatible model.
Nice, that's great. And another question on here is, can we print metal? And I can answer this one also, but the basic physics on the machine are that this one is set up for plastic resins, and the curing with metal is just a little bit different. DMLS technology and the PolyJet are just strictly different in the background, so we can't essentially mix. That would not be one of the 6 materials to go on this machine, but there are other technologies out there that can print metal and get you what you want in 3D print prototypes for metal.
Just let us know if you need metal, but yeah, this machine's that's not its purpose.
Yep. And if there are any other questions, we can field those via email. We're also going to send out an ebook with some general information on everything we discussed here. It's going to have a little bit more detail that you guys can mull over in your spare time. There's also going to be some contact information from us if you want to shoot some other questions over or talk to us some more specifics about the machine or parts or something to help everyone understand more about the J750 new offering from Stratasys. So with that, well, thank you guys. Thank you, Dylan, for joining up in Seattle, and hopefully we can share more with you on the J750 in the coming future. Thank you all.
All right. Thanks, Derek.